Recall our example of Magnolia Inn's hotel chain that wants to build a new hotel near a new airport. And if you recall, we had information about price or payoffs in case we purchase and we actually have the hotel built in a certain location. And so if you remember, we could purchase location A or location B, or we could purchase the parcels at both locations or neither. And if the airport was at location A and B, we had these payoffs and we assumed these probabilities. And suppose now that Magnolia actually has an opportunity to obtain additional information. Right? So suppose they can hire a company to predict where the airport will be built. Would it be location A or location B? And this company asks to be paid $800,000 for their analysis. Remember, these numbers were in millions of dollars, so this is basically 0.8 in the units of payoffs, right? And we also know something about the quality of the information. And in the past, the company was correct in 70% of the cases. In other words, that they predicted the location when the airport was actually in that location with 70% chance or 0.7 probability, right? So the first thing we need to, we could evaluate this information directly, but the interesting thing to evaluate is the value of perfect information. So what I'm going to do here is calculate expected value of perfect information. Now, how can we calculate expected value of perfect information? Well, we have to first find out what will be the value if airport is built at location A, and what will be the value if the airport is built at location B. So if the airport is, let me copy this part. If the airport is at location A, what value are we going to get? Well, if this is perfect information, if the information says location A is the one that will be chosen for the airport, we should certainly choose to buy land at location A, because that's what's going to give us the highest value, right? And if the perfect information says location B will be chosen, then we should certainly choose location B, right? And this can be found by just maximizing the value from this column or from this column. Now, I hope you recall this is basically reversing the order, right? Before we had to decide first and then see where the airport is. But with perfect information, we first see where the airport is, and then we can choose whatever is the best value for us. So, right, basically, I can calculate the value when the information says A as maximum of all possible values for all my decision alternatives, right? 13. And the same thing, I'll copy this, maximum here will be 11, right? So, right, and of course, this is equivalent of choosing, if airport is at location A, we choose location A to buy land, and if airport will be at location B, we choose to buy land at location B for sure, right? This is kind of obvious. Now, perfect information tells us this, will tell us this, but before we obtain any information, we have to be able to evaluate it, right? Like if we hire this company and they give us imperfect information, we have to find out first if this information is worth for us $800,000 before we actually get them to work, to their analysis and report to us, right? So we have to commit to the value. So we have to evaluate information before we obtain it. Now, what's the probability that the perfect information will tell us A or B? Well, we don't know any better than our prior probabilities, right? If the prior probability for us that the airport is at location A was 40%, the same probability is our best belief that perfect information will tell us that it's going to be 4%. So I can call this, right, probability that information will predict X, right, where this is X, and this is value if information will predict X, right? So this is if the information predicts A or B, the value will be 13 or 11, and this is happening with probability 40% or 60%. Now we're ready to calculate expected value with perfect information. Expected value with perfect information will be here, will be some product, right, will be expected value of these probabilities and these values, right? Why am I calculating it like this? If I have perfect information, I will choose accordingly. Perfect information will tell me A with 40% chance, and then I will get 13 million of payoff, and 60% chance it will take me B, and then I will get 11 million of payoff, right? So my expected payoff is probabilistic average of those two numbers, 13 and 11, and recall I obtained them by always choosing what the information is saying, right? This is perfect information. So expected value with perfect information is, as you can see, as you can see, the expected value of perfect information is 11.8 million. And recall that before, expected value without any additional information was 3.4 million. So I can copy it here just to organize my thoughts. Without perfect information, the expected value was this 3.4, right? So this was the optimal choice before, when we didn't know where the airport is, right? So you see this is quite a significant increase. So we can say expected value of perfect information, which is the EVPI, which we want to calculate, is the difference. How much the value increases if I have information that is perfect. So notice this is a lot. 8.4 is $8.4 million. The 8.4 is the value of perfect information. If you obtain it, you could increase the 3.4 million to 11.8 million, and the increase is by $8.4 million. Now, clearly, the information that is here not perfect is much cheaper than this, so it is definitely worth considering, right? The important thing is it's less. This is 0.8 million, whereas this is, right, almost 10 times, roughly 10 times bigger. So, the important thing is expected value of perfect information is higher than the cost of this information. So we cannot reject this information yet, because expected value of perfect information indicates it might be valuable. Now, we don't know what the value of this information, right? We still have a question of expected value of imperfect information. What is it going to be? We don't know. It could be anywhere between 0 and 8.4 million. But if it is higher than 800,000, right, 0.8, then it will be worth taking. Now, we can do this evaluation using a new decision tree that we will build with the information.